Welcome back. In today's lecture, we are going to see some kind of problems that is related to group. And obviously, I am not going to talk about numerical problem. Means I am trying to motivate you to go through the group. And due to that reason, I am telling you that how basically this notion, this mathematical notion of group structure is so much relevant for our application. Okay, that is our main aim to introduce this particular concept. Okay, and if you see the previous class, we have already seen this structure, and this is called algebraic structure, and we have already seen the significance of set. After that, Cartesian product, functions, we have covered magma, and after that in the previous class I have talked about the group. Okay, so whenever we are talking about the group, at that time we have some kind of set and with one binary operation, and obviously that should satisfy some kind of axioms. Axioms you can also interpret as those kind of assumption, and that assumption we are not going to prove. Obviously we are just believing on that assumption, and after that we are actually proceeding further. Okay, and if you see the relevance of that axioms, then from the actually physical point of view, you are able to understand why only these three axioms are presented there. Okay, in the previous class I have told you that if there exists some kind of symmetry, then it is possible to show that some notion of group comes into picture. Okay, you are able to also think like this, that if I have some kind of symmetry and if I apply symmetry on the symmetry, okay, then it is possible to show that you are again going to get some kind of symmetry only. Okay, so it means that whenever there exists a symmetry, then that will satisfy the property of closure property. Okay, and similarly all binary operation is telling that if A operate on A, then they will map to A. We have seen this kind of things during the definition of the binary operation. Okay, so binary operation may be anything here, whatever you want, you can assume, that doesn't matter for me. And here I am telling that symmetry, apply on symmetry. Okay, so symmetry, if you apply S, and I have some kind of operation, I don't know what kind of operation I am doing here, and after that I am going some kind of symmetry only. Okay, so that closure property will satisfy. You are able to see that if I do not change the symmetry, then that remains symmetry. That is nothing but the notion of identity. Okay, it is possible to show that you are able to invert the symmetry also. Okay, and due to that reason notion of inverse is there. And if you have three different symmetry, so either you can apply first symmetry on the second symmetry, and after that you can apply this whole notion to third symmetry, then and if you change the sequence, again it is possible to show that you are going to get same kind of symmetry. Okay, so what this is, if you go through the literature, then you are able to feel that mathematicians are very important, means intelligent group of person, and they know that I need some kind of notion which can actually able to capture some kind of symmetrical thing, or in another way, another more relevant way, some kind of invariance, some kind of invariant thing they're trying to capture. Okay, and they found that if they will satisfy these four properties, then that become more relevant for me. Okay, so let us try to see that how basically this is involved in our physics or any other places. And in the previous class, just in the sake of completion, I have again recalled the definition, and we have seen that all four property, identity, and after that obviously inverse, these kind of things are there. So this slide we have already discussed in the previous class. So now I am going to come to our application. Okay, so here you can see that I have talked about very fundamental things. Okay, during 10 plus 1 physics, you have already learned about the vectors, and I am also going to add something like rotation. Okay, so here what happens, that if you see the law of physics, okay, Newtonian physics, even if you can see, or even if you can see the special theory of relativity, means quantum physics, or all other, or particle physics, whatever, everywhere, in each and every place, it is possible to show that law of physics are invariant under rotation of coordinate system. Okay, it means that I have some kind of coordinate system, and suppose this is rectangular coordinate system, okay, or some other kind of coordinate system. It might possible coordinate system might be like this also. Angle is not 90°. Okay. Now, if you rotate this coordinate system, okay, like this, then also whatever law, suppose I am going to talk about fundamental law of Newton's. So all law of Newton is, if that is valid in this coordinate frame, you can assume x1 0 0, x0 0 0, and y0, and if you rotate this coordinate frame by some angle theta, that is called, now you can interpret this as a y1 and x1, like that, then it is possible to show that same law of physics is going to apply there. Okay, and this rotational symmetry of law of physics implies conservation of angular momentum. We all are actually familiar with that. Okay, here whenever we are going to apply rotation, you can see that two way I can do that. Either suppose I have to study some object, okay, so what I will do, that either I can rotate the coordinate frame. Why basically we are concerned so much with different coordinate frame? It is possible to show that some analysis is very difficult in some coordinate frame, but if you will change the coordinate frame, then analysis or synthesis become simpler. Okay, and you are able to apply lot of means you can simplify the calculation also. Okay, you are also able to get lot of geometrical insight if you are in comfortable coordinate frame, and due to that reason people are analyzing same kind of system in different coordinate frame, and in control system or system theory, actually choosing proper coordinate is very active area of research. Okay, if you are able to propose some kind of coordinate which will simplify the system, then actually that become new contribution. Okay, most of time people are doing, and in each and every area, even in power system, power electronics, machines and drives, computer science, everywhere people are searching towards the new coordinate frame. And I will tell you that what is guidelines, and that I will come when I am going to talk about vector space, and at that time I will taught you the basis, and you are able to understand that how to select the different coordinate frame, why selection is possible. So that kind of things I will discuss in later part. So for time being, you can assume that I have two different way. Either I can rotate the coordinate frame, and at that time object is fixed. Suppose this is object P. Another way, what you can do, you can make the coordinate frame fixed and just rotate the object only. Okay, so based on that, we have two different kind of rotation in physics, that is called passive rotation and active rotation. Okay, so in order to generate some kind of group kind of things, what I am going to do, I am going to start with passive rotation, but you can go through active rotation also. Okay, just at that time it is possible to show that you can just replace theta by minus theta. Okay, here you can see that I have recalled the definition of vector and scalar, and that definition is not as the same like whatever we have learned during our 10 plus 1 physics. At that time we are telling I have magnitude, I have direction, something like that. But here what I am telling, a vector is a mathematical object that transforms in a particular way under rotation. Okay, that I am telling. If you are going to rotate something, then some specific way that is going to transform. Okay, now what is meaning of scalar? that is again some kind of physical quantity called a scalar that is invariant under rotation. Okay, in this way now I am going to define or redefine the vectors. So if something is going to remain invariant under rotation, then I am going to treat that as a scalar. You can see that mass I have. Okay, so now I am going to ask you one very simple question. Suppose that if I am going to rotate this coordinate axis, okay, and here this is the point, okay. So what do you think, that suppose I am going to check the distance from this point to this point, so that is going to change or that is going to remain the same? Distance is remains same under rotation or not, if axis is fixed? Anyone, could you please answer this? Antara, what do you think? Kartike, everyone, are you able to hear me? Yeah, distance remains the fixed. Okay, so and using that property, you can see that in this lecture I am going to tell you that notion of group comes into picture. Okay, let us try to see that. What I am telling, that I have some kind of coordinate frame, okay, and you can take that coordinate frame, any coordinate frame. So for simplicity, what I am going to do, either you can take in 3 dimension or 2 dimension. Okay, so suppose you are in 3 dimension. Okay, sometime it is easy to visualize in 2 dimension, and after that you can move to the 3 dimension. Okay, so suppose that here I have x0, 0 and y0, and I have certain point P here, and suppose I have represented this point by some coordinate axis, that is x0 and y0, that is associated with that point. Okay, now what I am going to do, I am going to fix this point. I am just going to talk about the passive rotation. And what kind of operation I am going to do now, I am going to rotate this axis. I am not going to rotate the object. Due to that reason, I am telling this as a passive rotation. And you can see that in this particular coordinate frame, that new coordinate frame x1 and y1, I have some kind of same point can be represented now by px1 y1. Anyone has confusion? Okay, why same point in different coordinate, that is represented by different coordinate? Anyone has confusion? I think that it is pretty easy, because whenever I am representing some point, it means that we are, and if this is something like, if this angle is 90 degree, at that time how basically we are representing, we are telling that x0 is nothing but distance from here. So for that we are dropping perpendicular from here, and after that in order to represent the y, we are dropping perpendicular from here, and in this way we are telling what is x0 and y0. Okay, in this rotated coordinate frame, you can see again that angle remains the 90 degree. Here I am telling that these two coordinates make 90 degree again, but that is just rotated by theta. So everything is rotated by theta, and here again you can see that this distance from here to here, now that is we are telling that as a x1 and this as a y1. Okay, in this way this coordinate point is represented in 2 different frame. Okay, similar kind of things I am generalizing for third order, 3 dimension. So in 3 dimension you can see that any point, how many coordinate is required to represent any point in 3 dimension? Anyone? Could you please tell me how many different point? 3 point. Okay, so what I am going to do now, that I am going to represent some point here. This point I have given name V, and V has 3 components, V1, V2 and V3. Okay, so most of time we are using column vector to represent some point. Okay, you can use actually row vector also, but preferably people are using that. Okay, so I have used V1, V2, V3. Okay, mathematicians are doing that. Okay, now what I am going to do, I am going to rotate this whole coordinate frame by angle theta, and that is passive rotation. And after that what we found, that same point in rotated frame, that is represented by v dash, v2 dash and v3 dash. Okay, so it is possible to show that since same point is represented in you can treat this as a inertial frame, and you can tell that this another frame that make theta 1 with respect to that inertial frame. Okay, so it is possible to show since point remains the same and we have rotated this new frame with respect to existing frame by theta, due to that reason they are somehow related. Okay, and it is possible to show that always there exists some kind of matrices whenever we are going to rotate something. Okay, I don't know what kind of matrix this is R, but this has 3 cross 3 entry. Okay, and each entry is some kind of real number. Okay, it is possible to show during school time also. You might have done several times this kind of calculation, that suppose that I have some kind of point P in coordinate frame x0, 0 and y0, and you have to represent same coordinate frame in x1, 0 and y1, and it is possible to show that at that time we are going to show that basically this kind of matrix comes into picture. Okay, so you can actually verify by yourself. It is not difficult to verify, due to that reason I am telling. Okay, so now what happens, it is possible to show that one can represent x1 y1 by this and here x0 y0. Okay, so for simplicity what you can do, you can just assume that this is unit coordinate, and just what you can do, you can keep projection here. So from that it is possible to show that angle is cos theta minus sin theta and cos theta. So in this way I can able to represent 2 points. I am telling that I don't know this matrix in 3 dimension, but some matrix R comes into picture. Okay, now what I am telling, it means that these two vectors, okay, actually v and v dash, that object remains the same, but their coordinate in 2 different frame is related by some kind of matrices. Okay, so also here what we are able to observe now, that what is relation between v dash and v, and based on that relation I am going to give you idea that how basically R is going to behave in the general case, even if 4 dimension n dimension. Okay, because it is very difficult to do same kind of calculation for the n dimension. Okay, and due to that reason I need some kind of relevant theory. Okay, such that we can able to guess the form for the n dimensional coordinate system after some kind of rotation in n dimensional plane, even if I don't know the coordinates, even if I don't know, I do not want to do the calculation. Okay, so here you can see that first what I am going to do, I am going to calculate the length. Okay, so suppose this is the vector in this coordinate frame x0, 0 and y0. Okay, so it is possible to show that length of this vector. Okay, you are able to calculate length of this vector by dot product also. Okay, or you can see that I can able to write this as a v1, v2, v3, 1 if I will keep here, and v1, v2, v3. So you are already well aware that whenever we are calculating this distance, that is v1 square plus v2 square plus v3 square root of that. Okay, if this is 0, if this is something else, then v1 minus that point, v2 minus that point, and v3 minus that point. That kind of things we have already learned during our school time. Okay, so in this way I can represent the distance, okay, v square. Now what I am going to do, that I am also going to represent the distance v dash in the another coordinate frame, and another coordinate frame at this moment I have, that is x1, 0 and y1. Okay, at this moment it is possible to show now again distance v transpose v dot. Okay, so either you can write this notion or you can write this, both are exactly the same. Okay, both notion are exactly the same. Okay, so now what I am telling, that if you represent in this way, okay, So V transpose V dash transpose V dash, I can able to write RV transpose RV. Why? Because I have already assumed that I don't know what kind of matrices that is involved. Okay, so I have done calculation for second order case, two-dimensional case, and after that what I found that some matrices that comes into picture. Now I am going to guess the form of this matrices for any order case. Okay, 3 dimension, 4 dimension, n dimension, I don't know. Okay, so for that, now you can see that what I have done, I have rotated the coordinate frame with respect to some kind of fixed axis, and just I am going to substitute from here. And if you substitute from here, you can see here that actually even if coordinate system will rotate, but length of something that is going to remain the constant. Length is not going to change, and due to that reason, now only one possibility that whatever matrices R transpose R, that should be identity, then only I can give that length remains invariance. Okay, or length is a scalar quantity, you can tell in another way. Okay, so if this kind of structure comes into picture, then I can tell that during the rotation length remains the same. Okay, or I have already told you that whenever we are talking about the rotation, at that time in physics we are also talking about the conservation of angular momentum. Okay, so we are telling that okay, conservation of angular means momentum is preserved because I have some kind of symmetry with respect to rotation. Okay, now what we are going to do, we are going to try to understand this particular matrices with help of some calculation based on the matrix. Okay, so what we found that in matrix theory I have some kind of matrices, some class of matrices which is going to behave like this. Okay, and for that matrices I have very special name that is called orthogonal matrices. Okay, and what is meaning of orthogonal matrices? So an orthogonal matrices as a square matrix. Okay, you can see here that during rotation always whatever matrices that is going to comes into picture, that is a square matrix. Okay, in 3 dimension that kind of matrices is 3 cross 3 matrix, similar for n dimension. Okay, so what we found here also in matrix theory, that a orthogonal matrix is a square matrix whose column and row are orthogonal unit vector. Okay, and if row and column are orthogonal unit vector, then that vector we are also telling orthonormal, and that will satisfy this kind of property R transpose RT transpose, and due to that reason that will implies RT transpose equal to R inverse. Okay, what does it mean? That if you take the transpose of that matrix, that is exactly equal to the inverse of that matrix. Okay, and you can see that similar kind of matrix basically appear whenever I have rotated, whenever I have done the passive rotation. Okay, at that time this matrix is involved. Okay, now let us try to understand the property of this matrix. You can see that if I want to construct some kind of matrix which is called the orthogonal matrix, so for one dimensional case I have two options. Either I have 1 or -1. -1 is missing here, so -1, and we can interpret that as an identity or reflection about the real line. Okay, so one dimension, that is not a problem because that will satisfy all property, whatever property I have stated in here. Let us come to the 2 dimension. Okay, so 2 dimension, I am assuming that I have some kind of a square matrix and their entry is A, B, C, D. Okay, now I am going to construct some kind of matrix which will satisfy this kind of definition. Okay, and in that way I can also able to guess that kind of matrix, if I have 2 dimensional some kind of quantity which is lying in 2 dimension, and if this axis is rotated, because same matrix comes into picture, RT R equal to identity, so I can able to correlate this with this construction. Okay, so from the definition you can see that what definition is telling, that whenever some matrix is orthogonal matrix. I hope that you are already well aware about that. So if their column and row vector is unit vector, what does it mean? That a square plus b square, if you just either you can consider the column vector. What is meaning of column vector here? This is called column vector. What is meaning of row vector? This is called the row vector. Okay, so that should be unit. So it means that a square plus b square equal to 1 or c square plus d square equal to 1. Okay, and after that we have to make sure that that should be also orthogonal. So orthogonal means if you multiply ac plus bd, then that is equal to 0. Okay, now I have to guess the entry about abc. Okay, and it is possible to show that if you guess the abc, then I have, without loss of generality, I can assume that a equal to cos theta and c equal to sin theta, and automatically here, because I have to make sure that a square plus b square, and I have seen that this kind of matrix is actually generated whenever we are doing the rotation. Okay, and due to that reason I have some kind of trigonometrical function which is going to satisfy this kind of equality. Okay, so I have chosen a equal to sin theta, or you can select cos theta. So based on hit and trial I am doing. Similarly for c, you can select the opposite of that, cos theta and sin theta, and try to make sure that how to adjust signs such that this relation will satisfy. Okay, and if you will do that kind of calculation, it is possible to show that a equal to cos theta if you select c equal to sin theta, and b if you are putting as a minus c, or d as a, or b as a c, or d as a, because you have to make sure that ac plus bd that also equal to 0. So for that we are using the negative sign here, b equal to minus c or d equal to minus a. So I have two possibility. Okay, so I have this kind of matrix comes into picture. In place of a I have substituted cos theta. Now you can see that here if you take any row or column, that is unit vector. Okay, either you can multiply column vector of one to another column vector, dot product if you will take, then again that is 0. Okay, so that is orthogonal to each other, all column vector or row vector. Okay, so this is called rotation, and same rotation, and due to that reason I have, when I have started, at that time I have written the rotation matrix, and at that time I have written x1 y1 rotated coordinate frame, and after that I have cos theta minus sin theta and cos theta, and here x0 y0. So by projection also you can able to do same kind of thing. Okay, another choice I have, I can maintain a, and d and b I can maintain as a c. So for that this kind of matrix comes into picture. And if you are going to take some kind of reflection about some kind of angle theta by 2, it is possible to show that same kind of matrix is going to appear. Okay, and if you substitute theta equal to 90 degree, then that is nothing but reflection about this line y equal to x, and add theta equal to 90 degree, this matrix comes into picture. Okay, so what happens that if you see the rotation matrix, so rotation matrix, each rotation matrix that will satisfy this kind of property. So it is possible to show that always this kind of property will satisfy. Means in order to become some kind of group, you have already seen that there exists some kind of inverse. So inverse possibility is obvious, that is not a problem. Okay, each matrix, and if you take the transpose of that, then that is become inverse. Okay, another property that is that if you multiply two rotation matrices, then again that will give us only rotation matrix. Okay, because two orthogonal matrix, if you multiply any two orthogonal matrix, then itself that is orthogonal matrix. Okay, so with respect to multiplication, it is possible to show that this matrix is going to form some kind of group, all property. Okay, so first property, closure property will satisfy. associativity is satisfied because order, whatever way you can apply the order, that doesn't matter. Okay. Second property in that is identity. You know that how to define the identity, that is not a problem. Okay. And after that, here inverse is also obvious. So same kind of things I have written. A reflection is one inverse, which implies that reflection matrix is symmetric, means equal to transpose as well as orthogonal. The product of two rotation matrix is rotation matrix, and product of two reflection matrix is also a rotation matrix. Okay, so all three property that is going to satisfy. What I mean to say that since I have selected two different coordinate frame, okay, and what I am going to do now, that my coordinate frame is rotating, okay, and what I am telling that I am going to analyze some object and distance of that object. So we know that distance either I can measure from this coordinate frame or this coordinate frame. If origin is fixed, then that remains the same. Okay, so automatically some kind of group kind of notion comes into picture. Okay, anyone has confusion? Now in the next class I will show you that whenever you are applying the Newton's law, at that time some kind of restriction comes into picture, because I have to make sure that something is going to remain invariant. Okay, and whenever this kind of invariance condition comes into picture, then automatically some restriction comes into picture. Okay, now here another thing is called a special orthogonal group. Okay, what is meaning of a special orthogonal group? So whenever you are going to deal with any robotic system, any kind of system where rigidity is required, means, or rigid motion, means translation plus rotation we are going to talk, at that time it is possible to show that this kind of group comes into picture. Okay, so what is property of this group? Okay, a special orthogonal group. So first property is that R transpose equal to R inverse. Okay, column and row are mutually orthogonal, that kind of things, and each column and row is unit vector, and another possibility is that determinant R equal to 1. Okay, so this kind of definition of the orthogonal, a special orthogonal group we are telling. So now we are going to check that if I believe on this 4 property, then why this is going to form some kind of group. Okay, and that is called a special orthogonal group of order n. So you can see that in order to show that something is group, I have to show 4 properties. One is closure property, another is identity, after that inverse, and after that is associativity. Okay, so what I am going to do, I am going to assume that I don't know what is x, but x is some element of the special orthogonal group. Okay, which will satisfy all 4 property. Okay, it means that whenever something is from a special orthogonal group, so R transpose, because this what this expression is telling, R transpose R equal to R transpose, that is identity. Okay, so this relation is satisfied, and determinant of x equal to 1. Okay, by the property of this definition. Okay, so with help of this, now I am going to show something more, that first property, and that property what I am going to see that, okay, what I am going to do, I have some element, okay, and each and every element you try to see from here, that is going to represented by x and their transpose x. Okay, so now if I will take some kind of element x1 and x2 in place of x, okay, and if that belongs to SON, okay, and what I am going to do, that I am going to prove that if x1 and x2 individually belongs to this, then x1 and x2 also belongs to this. Okay, so for that, what I have to prove, that multiplication of this x1 x2 transpose x1 x2 both are identity. So that kind of things I have to establish. Okay, same kind of things you can see here, that x1 x2 transpose and x1 x2, okay, and transpose of you know that AB transpose equal to B transpose A transpose, and due to that reason I can write like this. And again, since x1 and x2 are the element of the orthogonal group, also a special orthogonal group, due to that reason R transpose R equal to identity. So, and obviously if you multiply something with the identity, then x transpose x2 transpose and x2 comes in, again that is identity. It means that multiplication also going to belongs to the same SON. Okay, anyone has confusion, then please let me know. Now what I have done, I have selected 3 element. Okay, so this will closure property. After that I have to prove the associativity, and you can see that associativity is also obvious. Okay, now what I have to do, n cross n identity matrix you can take, that will, if you apply n cross n identity matrix to any element, then that element is not going to change. Okay, so that works as a identity matrix, and that will satisfy all property of the definition. Whatever property means determinant equal to 1, whatever property I have told so far, that will satisfy by identity matrix. So please check for any identity matrix, you can check that all 3 property is going to satisfy. Okay, so please do by yourself. Now inverse, we know that inverse of something is x transpose equal to x inverse. So inverse, each element has inverse, and due to that reason, whenever I have a special orthogonal group, okay, that will satisfy the all property. And due to that reason, whenever some, or in another way, because we are writing the definition, okay, so what I am telling, that if these all 4 definition is satisfied, then that is form some kind of group. Okay, so now since this is also orthogonal, due to that reason people has given name a special orthogonal group. Okay, and this is very, very important. Why this is very, very important, I will tell you. That in 3-dimensional space, what happens, that suppose I have in 1-dimensional space, everything is very, very easy. Okay, suppose what you can do, you can take some kind of ball. Okay, and what you can do, that you can fix this ball with this kind of a string, and after that you can move it. Okay, if you know the theta, then by knowing theta dot, means d theta by dt, you are able to calculate the angular momentum, or angular momentum, not angular velocity. Okay, so by calculating d theta by dt, you are able to know that what is angular velocity. Okay, but if you are in 3-dimensional plane, at that time what is difficulty, that when something is rotating, then 3 angle is actually changing, that is with respect to x, with respect to y, with respect to z, and all are somehow related. Okay, so now what happens, omega is depending on theta phi psi. Suppose that one angle with respect to theta, another with respect to y axis is phi, and z with respect to psi. Okay, so omega is now function of theta phi psi. Okay, so I cannot tell at this moment that theta dot equal to theta dot, suppose theta is angle with respect to x, that is omega x, and phi dot is omega y, or psi y is omega z. That kind of things I cannot tell, because everything is depending on each other at that time. But one can see that rotation, from the property of this special orthogonal group, I know that rotation will, suppose rotation matrix is function of theta, that will also always satisfy this kind of relation, r theta equal to identity. Okay, and if you differentiate it, it is possible to show that you are able to get the expression of the angular velocity in 3-dimensional plane. Okay, and due to that reason, you can see that this property, or property of group, is again very, very essential whenever we are going to talk about the 3-dimensional object in some object in 3-dimensional plane. Because at that time, if they are doing some kind of rotation, at that time I have to calculate the angular velocity. Okay, so what we have observed so far, that whenever I have some kind of rotation, and something is going to remains invariant, then some notion of group comes into picture. And obviously, since I have to characterize, I have to capture that, due to that reason I have to involve algebra. Okay, and for that I am going to involve the matrix algebra. Okay, but abstraction, whatever abstraction is there, that is abstraction of group is there. Okay, now let us try to understand another thing. What I am telling, that suppose that I have some object. Okay, again in system theory and control theory, I am telling that whenever I have some kind of differential equation, I have something like that. I am representing differential equation like this, or representing differential equation like this. We have already seen the representation. Or I have, suppose I have force system, so I have something like x or u, or more general way, x is also function of t, x and u. Okay, so everywhere you can see that whenever I have a state, then a state x, if that belongs to n, then I can able to represent that by n tuples of tuples of real numbers. Okay, now it is possible to show that these tuples form a group under the component wise addition. That kind of things I am telling. Okay, so whenever you are going to do component wise addition, okay, it is possible to show, because I am just involving one operation, so I am able to find the identity matrix also. Okay, I am also going to talk about what is inverse of each and every, so please try to do by yourself. Okay, so that is again, that is going to form the group. Okay, so all state vectors, okay, if you are just going to take the component wise addition, then that form a group. Okay, another thing that you might have seen, that whenever I am talking about any motion, then motion is either translation and rotation, or rotation. Okay, or both of, or combination of translation and rotation, that is called rigid motion. Okay, so far what we have seen, that whenever rotation involved, then notion of group comes into picture. Okay, now we are going to look through that if translation also, if translation happens, again some notion of group comes into picture or not. Answer is yes. Okay, let us try to see that. I have taken very simple situation. Suppose P and Q in two-dimensional plane. So whenever I am writing R2, it means that X also belongs to some kind of real number and Y also belongs to some kind of real number. And what I am telling, that fixed point and transformation T is defined like this. What I am doing, I am translating. Translating means I am moving from one point to another point. So suppose that after translation, this coordinate x and y, now that is going to change by x plus p and y plus q. Okay, so there is no same change in x and y, some different change in x and y. So that now what I have to do, I have to prove that this will satisfy some kind of property of group. Okay, so what you can do, you can take two translation. Okay, and after that you can define the composition function. Okay, so you might have seen that during our school time, teacher has given lot of emphasis towards the composition of two functions. Okay, so we are able to see the see their application. Okay, so if you do composition of two translation, it is possible to show that again whatever things that comes into picture. Suppose here x and y first move by p and q and then r and s, then it is possible to show that from one point, if you see, and if you do p plus r translation in x direction and q plus s translation in y direction, then you are going to move to the same place. Okay, so it means that with respect to composition, okay, this form a group. Okay, and inverse you already know, identity you are just, you can put 0 0, then there is no translation x and y. Okay, so that is identity. And inverse you know that what if I will move from here to here, after that how to do reversal of that. Due to that reason I have written minus p and minus q. Okay, and it is possible to show that apart from this, that is also satisfy the commutativity property. Okay, so either you can do A operate on B or B operate on A, both are exactly the same. Okay, and associativity is always satisfied, please check it, and due to that reason translation is also satisfy the property of group. Okay, so now from here what become clear, that whenever some rigid object is evolving in a space, okay, either I can consider the translation or either I can consider the rotation, both are going to form some kind of group. Obviously operation is different, because here whatever operation I have suggested, that is just composition operation, and here in case of rotation what we have seen, that matrix multiplication kind of things comes into picture. But automatically both are things are going to form the group. Okay, so now you are able to understand this kind of things, that whenever, now this can be generalized for any physics, that whenever translation and rotation involved, then there exists some kind of group. Okay, I don't know what kind of group basically that is involved. Okay, so but using this kind of notion, it is possible to generalize, okay, that what kind of translation, what kind of rotation that is possible, because whenever some kind of translation and rotation, I have some kind of way to capture that translation and rotation. Okay, so what happens, that if you apply the group theory, lastly some algebra comes into picture where I can able to manipulate translation and rotation. Okay, and due to that reason this notion is important. It is possible to show that if system is complicated, then there are some more notion that comes into picture, that is called Lie algebra. Okay, again that is form some kind of group. I am not going to cover that in this particular course. Okay, after that, in this example I have just show you that if fx is all bijection 1 1 and on 2 function from set A to S to same set S, okay, then that is going to form some kind of group under the composition. Okay, it means that if you are moving in two-dimensional plane, okay, so what we have seen, that with respect to translation we have some kind of group. Okay, at that time we have used the composition of the function. Okay, at that time it is possible to show, now one can generalize this result, that all bijection whenever 1 1 on 2 kind of function is there, okay, then under some kind of composition of function they are going to form this group. Okay, and why this kind of law is very very important, we are going to show that in Newton's law we know that if I have some kind of inertial frame of reference, and if some frame is actually moving with uniform velocity, so same kind of law that is going to preserve there. Okay, so using this kind of example it is possible to show that why same kind of law is going to valid there. Okay, again symmetry, everything is involved. So I hope that you are able to understand this. Again, this is very very simple numerical exercise, that first I am going to show you that all bijection and bijection under composition of function, that is forming some kind of group. So you have to satisfy all whole property, closure property. After that you have to show that with respect to what operation basically associativity, identity and inverse will satisfy. Okay, so that four property, and you have already knowledge of function, so please check it. Okay, now another very much relevant application of the group, that is in cryptography. Okay, I am not going to teach you the cryptography, but I am going to give you the hint. Okay, so here you can see that cryptography, one of the algorithm of cryptography, that is called RSA algorithm, that is based on this particular way of construction. So one function is called Euler function, obviously that is given by Euler probability. So that is mapping from some kind of, here I am just going to talk about the positive integers. Okay, so positive integer, you can see here that phi, that is mapping from the positive integer to positive integer. Okay, and here I am not considering one, that is the meaning of this. Okay, so number of positive integer that is less than n and relatively prime to n is called Euler function. Okay, it means that if I have some number 6, then phi 6, if I pass through this function, whatever definition I have, then that will give us 2. And why that will give us 2? Because if you see the 6, so relative prime is 1 and 5 and their number is just 2. You all are already well aware that what is meaning of prime number. Okay, now you can see here that 5 8 is 4 because I have this. Now it is possible to show that 5 10 is nothing but that is 10. Okay, 4 and element is 1 3 7 9, that is relatively prime. These kind of things are there. Now it is possible to show that if you operate 5 10 with respect to mod 10, then this kind of table comes into picture. Okay, and again if you look through this table, then all property associativity, identity and inverse will satisfy. Okay, so this is the one of the way to construct some kind of function based on the prime number. Okay, and here this construction, if you see the 5 10 with respect to mod 10 and you know what is meaning of mod 10, suppose here if I operate 1 and 1 with respect to multiplication, so 1 and mod 10, that is 1. Okay, here 1 9 mod 10, that is 9. Okay, try to understand here 3, so 9 multiplied by 3, that is 27 and mod 10, that is 7. Okay, in this way I have constructed this multiplication table. Okay, and it is possible to show that this multiplication table is closed. Closed means if you operate any element you can take, and if you apply this kind of operation, so operation, this binary operation I have applied, and with respect to this binary operation I have all property of closure property, after that identity, inverse and everything is there. Okay, it is not difficult to check that inverse of 3 is 7. Please do by yourself. Okay, so just verify all properties satisfy. Okay, and in this way we are proving that if I have some kind of Euler function phi, so with respect to modulus operation, that is going to form some kind of group. Okay, now what people has done, people has used this kind of notion in order to develop some kind of crypto system. Okay, what basically in crypto system we have two different key. One is called public key and another key that is secret key, private key. Okay, so now by taking two prime numbers we have to basically generate two different key. Okay, and we have to make sure that whatever public key we have generated, that is not guessed by someone. Okay, so suppose that if you enter your password and after that some agency, even if that will see that that password, means that encrypted password, they are not able to guess that what kind of things we have typed. Okay, so for that we are using some kind of crypto system. Okay, so this is the mechanism. Using the use of group, we are trying to generate some kind of cryptography mechanism. Okay, so those who have interest in cryptography, again please try to read the group, and it is possible to show that you are able to develop different cryptography algorithm. Okay, so this algorithm is actually based on, again they have taken some kind of large number and large number p and q, they have defined some kind of n, and they have defined this kind of Euler function, and you have already seen the Euler function definition of Euler function, and after that E and D they have taken. So there are some way, okay, to do that, and in this way if you proceed, it is possible to show that you have some kind of unique private key. Okay, and using that you can able to decode the message. Okay, so what is my suggestion, that if you have interest in this kind of cryptography, then please go by yourself. Okay, our interest is not to read or to discuss cryptography system. I am just telling that how basically notion of group comes into picture in the crypto system. Okay, so far I have discussed about this. In the next class, what I am going to do, I am going to discuss the principle of relativity and determinacy. Okay, and it is possible to show that again notion of group comes into picture. Okay, and at that time now modeling is going to start. Okay, so first I am going to talk about the modeling based on first principle. And actually it is possible to show that whenever we are doing modeling based on first principle, particularly for the mechanical system, so at that time notion of group provide us some kind of restriction. Okay, and using that, in keeping in mind of that restriction, we are going to tell that where our modeling is valid. Okay, that is the topic of the next class. So with this remark, now class is in from my side. If you have any question, then please let me know. Anyone?
So, sir, in the previous classes where you showed some modeling examples of the rocket and simple pendulum,
Okay.
where is group applicable there in the modeling?
So I will tell you the next class. Actually, suppose that if you have there, it is possible to show that we have already assumed that there exists some kind of inertial frame. Okay, during mathematical modeling. Okay, I have most of time we haven't discussed that, we haven't written that, but we are assuming there inherently that there is some kind of inertial frame. Okay, then only we are able to apply F equal to ma, otherwise F equal to ma is not applicable. Okay, we all are, I hope that you are already well aware that if I have non-inertial frame, then how to convert non-inertial frame into inertial frame, we are applying some kind of pseudo force. Okay, so basically what happens that whenever we are doing the modeling, we have to understand that in which place that modeling is valid. Okay, suppose you have constructed some kind of rocket here. Okay, and here inertial frame is our earth. Suppose what you are going to do now, you have developed some kind of system. Okay, and you have sent that system on Mars, and what you are willing now that once that particular spaceship will land to Mars, then at there they will construct some kind of rocket. Okay, so what do you think, dynamics remains the same?
No, sir.
So obviously, and why? Because their frame of reference is different. Okay, so due to that reason, whenever we are doing modeling, we have to understand that under which frame, okay, our modeling is going to work, and why that kind of restriction comes into picture. So that kind of things we are going to understand. Okay, so
Okay.
basically most of time what happens, students are applying law blindly, but they don't know under which space basically some law is working or not working. Okay, so using notion of group, we are trying to understand that what kind of restriction comes into picture. Now group also tells us that suppose if new situation comes into picture, then how to handle that. Okay, so that is another implication of the group.
Okay.
So what is my conclusion? Whenever you have some kind of symmetry in physics, then you have some kind of notion group. Okay. Now, since you know that there exists some group, now you have to just find the operation. Okay. So you have to guess operation. Now, it might possible sometime operation addition, but in this you can see that in cryptography, what kind of operation I have? I have operation mod 10. Okay, if I have constructed something like phi 10. Okay, so it means that mod n operation is there. So if you know group is there, then you are able to guess some kind of operation. That is the beauty. Any other question? Okay, thank you very much. Actually group is not so easy topic. Okay, it requires some kind of group ring field, that is very tough topic. Okay, but I have just give you the overview. Okay, so such that whenever you join some kind of software company, or even if some kind of finance where cryptography, when some kind of modeling or these kind of things are involved, then you have to understand that I can able to define some kind of new way of operation, such that I will come up with some new notion or some new kind of algorithm. So how to come up with new algorithm, then you have to understand the theory. Okay, so if you are able to understand the theory of group, then you are able to guess the operation. Okay, that is the main motive. So thank you very much. I have another class, so I am going to end the today's class now.